In this video we're going to be looking at sketching quadratics. Okay, so a quadratic always has the same shape. We can call it a parabolic shape. So quadratics are literally parabolas. Now we drew a quadratic in the lesson and the quadratic had this sort of shape. Okay? It might look like this or it might be this but upside down. Okay? So these are parabolas. So quadratics always look like this sort of shape. We looked at this example in lesson. Okay. So I'm going to sketch this now. We plotted it in class, so I'm just going to put it on this graph. Put the points on the axis, and it looks like this. Okay, so someone asked if we had to do the table of values to sketch it. Now we don't, we just need to know certain things about this quadratic. There are certain interesting points in this quadratic. They are here and here. These are called the x-intercepts. There's this point here. This is called the y-intercept. And there's this point here, which is the minimum. If we know this information, if we know the x-intercepts, the y-intercepts, and the minimum, then we can have a fairly good sketch of our quadratic. We don't have to plot it exactly, we just want a sketch, something that looks about right. Okay, so let's go through each of these ideas in turn. So the x-intercepts first. So the x-intercepts are when the graph crosses the x-axis. Okay? If we look at the example on the bottom left here, the x-intercepts, well, when does it cross the x-axis? It crosses at -3, 0 and -1, 0. These are the x-intercepts. If we look at the first examples, on the top left here, the x-intercepts are here and here. Well, when does the first x-intercept happen? Well, we know the y value is 0 and it has some x value, so we could call it a0. This one here, again, the y value is 0 and it has some x value, say b. So we don't know when they happen, but we know that the y value is 0 for both examples. In this example here, there aren't any x-intercepts. It doesn't cross the x-axis at all. Okay? So in conclusion then, the x-intercepts happen when the graph crosses the x-axis, but we know something about that point. We know that the y value, we know it's when y equals 0. If we look at all the coordinates where this happens, the y value is 0. Let's apply this to the graph. So say we didn't plot it, and we wanted to find the x-intercepts. We know that y is 0. We also know that the graph itself, is x squared plus 4x plus 3. Since y is 0, we can replace the y here by 0. We can say 0 equals x squared plus 4x plus 3. This is now a quadratic equation which we could solve. To solve this quadratic equation, we would factorize. If this is true, then x is either -1 or -3. So we now know the values of x that make this equation make sense. These coordinates are -1, 0, because the x value is -1 and the y value is 0, or -3, 0, because the x value is -3 and the y value is 0. These are the points that we plotted in the original equation. Okay, so this is how to find x-intercepts if you don't have a plot already. Next, let's look at the y-intercepts. So, the y-intercepts in the example we're looking in the example bottom left is 0, 3. This is when it happens. This is when it crosses the y-axis. Over here, it's 0 along the x-axis and some height. Say the y value is c. Here again, it's 0 along the x-axis and some height d. So the y-intercept is when the graph crosses the y-axis, but it's also when the x value is 0. This is true of all the x-intercepts in these examples. So when is the x value 0? Well, we know that the graph itself is y equals x squared plus 4x plus 3. So when x is 0, we can just replace x by 0 to give us 0 squared plus 4 times 0 plus 3. So y must be 3. So in our example bottom left, this is a more algebraic way to find the y-intercept. The y-intercept in this case is 0, 3. So if we didn't have the plot, this is how we would find the y-intercept. Okay, finally, let's look at the minimum. So the minimum point is highlighted on the bottom left. I'm going to give another name for this. It's also called a turning point. We'll go through turning points a bit later in the course. Okay, so in this particular example, the turning point, or the minimum point, happens at -2, -1. In this example, there's the minimum point, and over here we have a maximum point. So in this upside-down quadratic, it's a maximum point rather than a minimum point. Okay, so to find a minimum, you're going to need to use the method of completing the square, and I'm going to explain how this works. Okay? So if we didn't have the plot, to find the minimum, we would complete the square. Let's look at the quadratic we've got, and let's complete the square on it. So we would half that coefficient of x, we would subtract 2 squared, which is subtracting 4, and add the 3. If you're not sure about completing the square, maybe look at the previous video on completing the square to review this method. This leaves us with the completing the square form of x plus 2 all squared minus 1. Okay, so I'm going to put this part in a box. Now, when I'm talking about this information, remember I'm trying to find the minimum. I'm trying to find the minimum of this expression, the lowest value. Looking at this particular bit inside the box, this is something squared. It's x plus 2 squared. So x plus 2 squared, when you square something, it's always bigger than or equal to 0. You can't square something and get a negative answer. So when you square something, it's always bigger than or equal to 0. So this is always bigger than or equal to 0 because we're squaring something. So the bit inside the yellow box is always bigger than or equal to 0. If we're trying to minimize the whole thing, okay, the minimum will happen when the box is as small as possible, when that yellow box is as small as possible. So when x plus 2 squared, well, when is that as small as possible? That happens when it's 0. It can't be any smaller than 0, so it's a minimum. It's as small as possible when that box is as small as possible, so when that box is 0. When does this happen? This happens at x is minus 2. So to minimize this function, we need to find when x is minus... we need to find out when that yellow box is 0, which happens when x is minus 2. Now the graph itself is y equals x squared plus 4x plus 3. So the minimum y value, well, when x is minus 2, the box is 0, so y is equal to minus 1. Because if the box is 0, then the y value is just what's left over. So if that yellow box is 0, the y value is just what's left over, which is minus 1. Okay. So our minimum point matches the minimum point on the plot. Okay, notice also, if I were to draw this line here, notice this is a line of symmetry. So just one extra add-on to this. This line here through the minimum point is the line of symmetry. The equation of this line is x equals minus 2. We can call this the line of symmetry. Okay. So we're going to leave this here for now. So the point of all of this was, if we want to sketch a quadratic and we don't want to plot it, we need to find out the x-intercepts, the y-intercepts, and the minimum. To find the minimum, we will need to complete the square. We're going to do more practice of this in lessons. Okay, make sure you've got complete notes on this, and if you have any problems with this, then let me know before the lesson, please. Thank you very much.